In this video, we're going to talk about transforming exponential functions. The learning targets for this video are we're going to be able to talk about how changing parameters in an equation affects the graph of an exponential function, and we're also going to be able to graph transformations of exponential functions. First, we're going to review how transformations work for the parent functions that we've talked about so far in this class. We've talked about absolute value functions, and we've talked about quadratic functions. Looking at absolute value functions, the parent function for an absolute value function is y is equal to the absolute value of x. That's the simplest form of absolute value. If we want a reflection, which is a reflection over the x-axis, what we're going to do is put a negative in front of the absolute value bars. And this is going to change our graph to be upside down. You can see from the parent function to this graph, all I did, it has the same slope on both sides of the vertex, it's just flipped upside down. So those points, and you can also say those points are reflected over the x-axis. And all you need for that is a negative in front. If I wanted a horizontal shift, I would add or subtract something inside of the absolute value bars. So if I see that I'm subtracting 3 inside of the absolute value bars, this means if I'm subtracting something, it means I'm moving to the right. And in this case, I'm moving right 3. I can see from my parent function, if I look at the most important point, 0, 0, my vertex, my new vertex is at 3, 0. And that's because I moved the point 3 to the right. The vertex that I started with, 3 to the right. Then if I wanted a vertical shift, what I would do is I would add or subtract something outside of the absolute value bars. And if I add 2, when I add something, it means I'm moving up. And so in this case, I'm moving up 2. I started at 0, 0 for my vertex, and now I'm at 0, 2 for my vertex. So y increased by 2. Every point increased by 2. And you can look at every single point. You don't have to just look at the vertex. You'll see that every single point moved up 2. Just like when I moved right 3, every single point from here to here changed. It moved right 3. If I look at a combined shift, if I wanted a combined shift, which means a horizontal shift and a vertical shift at the same time, I could add 2 inside of the absolute value and subtract 1 outside of the absolute value. I could have something happening inside and outside. And if I had this, I would know that if I have something being added inside of the absolute value, means I'm moving left. So in this case, left 2. And if I have subtracting outside, it means I'm moving down. And in this case, down 1. So what I'm going to do is I'm going to find my new vertex. My new vertex, I'm going from what in the parent function, it would have been 0, 0. Well, I'm moving left 2 and down 1 because of that extra stuff that I see. Besides y is equal to the absolute value of x. So I'm moving left 1, 2, and down 1, and this is my new vertex. And then I'm going to find what is my other points. Well, I know that the slope didn't change, so in the parent function I was going up 1, right 1, up 1, right 1. So that's what I'm going to be doing in this function. Here I'm going to be moving up 1, right 1, up 1, right 1. And then I know I have the same points reflected through this imaginary line of reflection in the center, and I will have the points left 1, up 1, and left 1, up 1, and this is my absolute value function graph with those combined shifts. For quadratics, y is equal to x squared is the most basic function of quadratics. It's the parent function. Again, if I have a negative in front, I know that that's a reflection over the x-axis, or everything is moving upside down, or the graph is moving upside down. I can't spell upside down. For when I have something being, or when I have when I'm subtracting 3 inside of the parentheses before squaring, so I'm subtracting 3 from my input before doing that really important thing in quadratics, squaring, I'm going to see that all the points from this graph to this graph I see are moving right 3. I started at 0, 0 for my vertex, and now my vertex is at 3, 0. So this is also right 3, just like it was for the when I subtracted 3 inside of the absolute value bars for absolute value. And then if I add 2 outside of, if I add 2 outside of squaring, I also see that I am moving. Oh, why did I say up 3 here? This is up 2. I also see that I'm moving all points up 2. So I started at 0, 0. Now I'm at 0, 2. And then for the combined shift, if I add 2 inside and I subtract 1 outside, that's left 2, down 1. And my new vertex is going to be at -2, -1. And then I know that I will have a point 1 to the right and 1 up, and 1 to the left and 1 up, just like my parent function, because the slope didn't change. And then I'm going to combine these in a curved fashion because this is a parabola. What I see is the same thing for reflecting horizontal shifts and vertical shifts. I see the same thing for both types of functions for absolute value and quadratics. These shifts or these transformations are going to be the same for every type of function. So they're going to be the same for exponential functions as well. So the only difference is that for for exponential functions, you won't always have the same parent function. There are different parent functions for every different base. So something that's really important, parent function will look different for every base. And what the parent function will look like is something like y is equal to 2 to the x power. Whatever base you have to just the x power, nothing else. So another example, so that's one example. Another example will be 3 to the x power, or y is equal to 4 to the x power, y is equal to 5 to the x power, etc. Your parent function is just going to be whatever base you have to just the x power. In this case, we're going to be working with base 2 because that's an exponential function you're going to see a lot of. So if I have the parent function for base 2, it's just y is equal to 2 to the x power. What I'm going to do is I'm going to create the table for this. So what's the table going to look like for this? And I know the table, I want to pick values for x that are small so that it fits on my graph. And for most cases, I'm going to pick -1, 0, and 1. So in this case, I'm going to pick -1, 0, and 1 as my x's that I'm going to plug in for the exponents. If I plug in -1 for x, I'm going to get 1/2. If I plug in 0 for x, I'm going to get 1. And if I plug in 1 for x, I'm going to get 2. So that's my parent function table. And I'm going to plot those points. So I have -1, 1/2, 0, 1, and 1, 2. I'm going to connect these points. And when I do an exponential function, I know I have a asymptote. So that's a line I'm not touching, and in this case it's going to be the x-axis, or y is equal to 0. So that's my horizontal asymptote. And that's going to be the case for every parent function of every base. Your horizontal asymptote is going to be y is equal to 0. If I want a reflection over the x-axis, or I want to flip this graph upside down, I'm going to have a negative in front of 2 to the x power if I'm talking about base 2. Just like for the other examples, I have a negative in front. So I'll have -2 to the x power. What's actually happening when I put the negative in front, like what's actually happening to my points, or the values in my points, I want to look at, so I have 1, 1 and 2, 2 here. 1, 1 and 2, 2 here. Those points reflected in the when I have negative absolute value of x are 1, -1 and 2, -1. And if I compare these points to the original points, all I did was I took the y value and I multiplied by -1. So to go from 1 to -1, I multiplied by -1. To go from 2 to -2, I multiplied by -1. So what I'm actually doing as I go from, or what I'm actually doing to the values of my points, when I see a negative in front, I am multiplying. So I'm going to multiply all y values by -1. That's what I'm doing. And so what I'm going to do is I'm going to take my parent function table, and I'm just going to multiply all of my y values by -1. I'm going to leave my x values alone. So I'm going to have a table with -1, 0, and 1. And instead of 1/2, 1, and 2, I'm going to have, multiplying these by -1, I'm going to have -1/2. Come on. -1/2, -1, and -2. So that's how the parent function changed. I'm going to erase this because I'm going to be doing different things every time. But these are the points that I'm plotting. So I have -1, -1/2, 0, -1, 1, and -2. And I'm going to connect these, making sure I don't hit the x-axis, because that's my horizontal asymptote. So y is equal to 0 is my horizontal asymptote. Okay, and then, as you can see, this graph is this graph flipped upside down. All right, if I want a horizontal shift, so that turned it upside down. If I want a horizontal shift, just like in the other two examples where I was adding or subtracting something inside or with my input, I'm going to be doing that in exponential functions as well. So my input in the case of exponential functions is in the exponent. So I will be subtracting or adding something in the exponent. For example, I might be subtracting 3. And if I am doing that, that tells me that I'm going to be moving right 3. Whatever I'm adding or subtracting, it's going to tell me my horizontal shift, if I'm moving left or right. If it's addition, I'm moving left. If it's subtracting something, I'm moving right. So if I'm moving right 3, I want to think about what that actually means for all of my points. So if I start with 0, 0, and 1, 1 on my original graph, my parent function, on the horizontal shift graph, I have the changed points are 3, 0, and 4, 1. What I notice is what I'm doing from these points to these points is and maybe it'll help if so 0, 0, and 1, 1 change to 3, 0, and 4, 1. And what I'm actually doing is I'm taking the x values and I'm adding 3. And that gives me my new x values. So I'm adding 3 to the x values. And that's what happens when you add, or when you move all your points right 3. You're adding 3 to your x values. So I'm going to do that in my original table. I'm going to move right 3. I'm going to add 3 to all x values. So what I'm going to do is I'm going to look at the x values that I started with. I have a -1, 0, and 1. I'm adding 3 to all of those to get my new x values. So my new table is going to look like this. I'm going to have 2, 3, and 4. And I'm still going to have the same y values. So I'm going to have 1/2, 1, and 2. And these are going to be the points that I plot. So 2, 1/2, 2, 1/2, 3, 1, and 4, 2. And then I'm going to connect these and make sure I don't touch the the x-axis, which is my horizontal asymptote. And that's what my graph looks like. All I did was I took these points and I moved them to the right 3. All right, for vertical shift, I know that if I'm adding or subtracting k, I know I'm moving up or down, just like I was in the other examples, or the other functions. So if I'm adding 2 to the x power on the outside, not inside of the parentheses, I know I'm moving up to all my points, which means what I'm actually doing is I'm adding 2 to all y values. So I'm adding 2 to all my y values, which means that if I look at my new table, I'm going to have, my new table is going to be -1, 0, and 1, still same x values, but my y values are going to change by I'm adding 2. So I'm going to take 0.5, which is 1/2, and I'm going to add 2. I'm going to take 1, and I'm going to add 2. I'm going to take 2, and I'm going to add 2. These are just the y values I have in my parent function table. And then I'm going to have 2.5. I'm going to have 2.5, 3, and 4. And then I'm going to plot those points. So -1 and 2.5, 0 and 3, and 1, 4. And then I'm going to connect these points. Also, what I want to keep in mind is that I have because I have a vertical shift, my horizontal asymptote is going to change as well. If I'm vertically shifting everything by 2, my horizontal asymptote is going to change as well. So if I see +2 here, I know that my new horizontal asymptote is going to be at y is equal to 2. That's my horizontal asymptote. So that's the line I'm not going to touch. I'm going to connect my points and make sure I don't touch that line. And that's my graph. And then if I do a combined shift, it's going to be the same thing. I'm not going to do that. I'm going to move on. All right, now we're going to do some examples. So if I have 2 times 1/2 to the x power, what I want to do is I want to first start with my parent function, whatever the table is for that, and then I want to do the transformations from there. So the parent function in this case is going to be y is equal to 1/2 to the x power. So that's the most basic of this exponential function, the base raised to the x power only. And what the table is going to look like is I'm going to have a -1, 0, and 1. And when I plug in -1, I'm going to get 2. When I plug in 0, I'm going to get 1. And when I plug in 1, I'm going to get 1/2. What I'm going to do when I see a coefficient in front, just like when I saw the negative in front, this means I'm going to multiply. So I'm going to multiply all y values by 2, whatever number I have in front. If it was negative, I would multiply them by -2. In this case, I'm going to multiply them by +2. And hopefully this is easier for you to see than the last examples we just did. My new function, which is going to be y is equal to 2 times 1/2 to the x, which is what I want, is going to be, I'm going to have -1, 0, and 1. But instead, my y values are going to be 4, 2, and 1 instead of 2, 1, and 1/2. And then I'm going to plot these points. So I have -1 and 4. I have 0 and 2, and I have 1, 1. And I'm going to connect these. I'm going to connect these and make sure I don't touch I didn't have any vertical shifts, so my horizontal asymptote is y is equal to 0. For number two, I'm going to have the same parent function. 1/2 raised to the x power, since that's my base. So I'm just going to copy what I already had. I have a table, -1, 0, 1, 2, 1, and 1/2. And here I have two different shifts. So I'm subtracting 3 on the outside, which means, actually I'm going to move this down a little bit to make it smaller. I know that that's subtracting 3, so that down 3 means that I'm subtracting 3 from all y values. I know this 2 in front tells me, whoopsies. A being equal to 2 tells me that I multiply all y values by 2. Just like order of operations works regularly, I'm going to do my multiplication first and then my addition and subtraction. So I'm going to multiply all y values first by 2, and then I'm going to subtract 3. And my new, once I do those two shifts, I'm going to have the function y is equal to, or the table for y is equal to 2 times 1/2 to the x power minus 3, which is what I want. And it's going to be the same x values, so -1, 0, 1. And then 2 times 2 is 4, 4 minus 3 is 1. I have 1 times 2 is 2, minus 3 is -1. 1/2 times 2 is 1, 1 minus 3 is -2. And I'm going to plot these points. So -1, 1. I have 0, -1. I have 1, -2. And then I know that my new horizontal asymptote is going to be down 3. So it's going to be, because that's my shift, it's going to be at y is equal to -3. So y is equal to -3 is my horizontal asymptote. And so when I connect these, I'm going to make sure that I do not touch the, and you could do a better job than I just did, the line y is equal to -3. All right, for number 3, I again have the same base. So I'm going to start with y is equal to 1/2 to the x power. That's my parent function. I have the table -1, 0, 1, 2, 1, and 1/2. And I'm going to see what transformations I'm going to do to that. So I have a -2 in front, which means I'm going to multiply all y values by -2. I have a +3. Oh, I only have 2 transformations. I have a +3 in the exponent, which means, let me make this, +3 in the exponent, which means I'm moving left 3. So that means that I'm subtracting 3 from all x values. Because when I'm talking about left and right, I'm talking about my x values. When I'm talking about up and down, I'm talking about my y values. So I'm going to subtract 3 from all of my x values. What I should have done is I should have wrote these a little bit differently. So I'm going to rewrite this table. I'm going to leave enough space for me to do that. This is 2, 1, 1/2. So I'm going to subtract 3 from all of my x values, and I'm going to multiply all my y values by -2. And my new table is going to be y is equal to -2 times 1/2 to the x plus 3 power, because I'm taking care of those two transformations. And this is these are the points that I want. My x's are going to be -4, -3, -2. My y values are going to be -4, -2, -1. So I'm going to have -4, -4, which is right here. I'm going to have -3, -2, which is right here. And -2, -1 right here. And first thing I really want to do before I do anything else is draw my new, or what my horizontal asymptote is. And there is no vertical shift, so it is the y-axis. Y is equal to 0, horizontal asymptote. And that's the line I'm going to make sure I don't touch. So this is my exponential function. I want you to try these 3 on your own. So pause this video and try these 3 on your own. All right, for number 4, I have y is equal to negative 3 times 2 to the x power. The only transformation that I see there is this negative 3 in front. So all I'm doing is multiplying. So I want to multiply all y values by negative 3. And the difference is I don't have the same base. So I'm going to have a different parent function, and that parent function is going to be y is equal to 2 to the x power. So y is equal to 2 to the x power. I'm going to have, I'm going to use negative 1, 0, and 1 again. But I'm going to have 1/2, 1, and 2. And I'm multiplying all of my y values by negative 3. And that's going to give me the function y is equal to negative 3 times 2 to the x power, which is what I want. And I'm going to have negative 1, 0, 1. But I'll have, for my y values, 1/2 times negative 3, which is negative 3/2. This is going to be negative 3. 2 times negative 3 is negative 6. I'm going to plot these points. So I'm going to have negative 1, negative... First thing I want to do is draw my horizontal asymptote, which in this case, since I don't have a vertical shift, is 0. And then I'm going to plot these points. So negative 1 and negative 1.5, 0, negative 3, and 1 and negative 6. So 1, 2, 3, 4, 5, 6 right here. And then I'm going to connect these and make sure I don't touch that x-axis. And that's my graph. For number 5, you should have, again, used that same base, that same parent function table. So negative 1, 0, I have a negative 1, 0, 1, and 1/2, 1, and 2. I want to leave space here so I could do the horizontal shift that I see that I have. I have a horizontal shift of negative 1. I have this coefficient that's going to tell me I'm multiplying my y values, and then I have this adding something. So first thing first, I'm going to start with order of operations, multiplication first. I'm multiplying all y values by 3. Another thing that I know that I'm doing is I am moving, so because I have this right, this thing is so annoying. Because I'm moving right 1, I know that I'm going to add 1 to all x's. And then because I have that plus 1 on the outside, I know I'm moving up 1, which means I'm going to add 1 to all y's. I'm going to start with my multiplication, so I'm multiplying my y values by 3. I'm going to add 1 to all my x values, and I'm going to add 1 to all my y values. And then I'm going to end up with y is equal to 3 times 2, so the x minus 1 plus 1, which is going to give me 0, 1, 2, and 3/2 plus 1, which is 5/2. And then I have 4. 1 times 3 is 3, plus 1 is 4. And then I have 2 times 3 is 6, 6 plus 1 is 7. And then I'm going to plot these points. So 0, 5/2, which is about... It's about here. Oh, it is like here. That's 2.5. And then I have 1, 4. And I have 2, 7. 2, 3, 4, 5, 6, 7 right here. And I know my horizontal asymptote is going to be, I have a shift of moving 1 up. So it's going to be at y is equal to 1. That's my horizontal asymptote. And when I connect these points, I know that I'm not going to touch that line. And then for number 6, what you should have saw is 3 transformations here. Your base is different, so you need a new parent function, which is parent function table, which is 3 to the x power. So I'm going to use negative 1, 0, and 1 again, but I'm going to have 1/3, 1, and 3. And then I know that I have this coefficient means multiply all y's by 2. I know this plus 2 means I'm moving left 2, so I'll be subtracting 2 from all x's. And then I know this minus 1 means I'm moving down 1, so subtract 1 from all y's. I should have done this a little bit better, so I'm going to erase this left-hand side and redo it. So I have enough space, -1, 0, 1, and then I'm going to do these transformations. So I'm going to start with multiplication. I'm going to multiply my y's by 3. I'm going to, that takes care of this. I'm going to subtract 2 from all x's. That takes care of this. And then I'm going to move down 1. So subtract 1 from all y's. So I'm going to do that, and that takes care of that. And then once I do all of these things, I'm going to end up with the table for y is equal to 2 times 3 to the x plus 2 power minus 1. So I'm going to have -3, and 1/3 times 3 is 1. 1 minus 1 is 0. I'm going to have -2, and 1 times 3 is 3. Minus 1 is 2. And then I'm going to have -1, and 3 times 3 is 9. 9 minus 1 is... Wait, did I mess up? I did, because you're supposed to multiply all of these by... You're supposed to multiply all of these by 2. So don't do that. You're multiplying all of these by 2. So I have to change what I have here. This is not that. Okay, so I should have -3 and 2/3 minus 1, which is -1/3. I have -2 times, wait, I'm sorry. 1 times 2 is 2, minus 1 is 1, and then 3 times 2 is 6, 6 minus 1 is 5. I hate this thing. 5. All right, and those are my points. First things first, I'm going to draw my new horizontal asymptote, which is right here. Y is equal to -1, and then I'm going to, let me see, y is equal to -1, and then I'm going to plot my points, so -3 and -1/3, what, that's not right, -3 and -1/3, -2 and 1, and -1 and 5, 1, 2, 3, 4, 5, right here. And I connect these and then make sure I don't touch y is equal to -1. And that's my graph.